Hi, I'm Professor Renee Taylor, and it's a great pleasure to be here today with my colleague and friend Marianna. Um, my role here at ANZUP is that I'm a translational scientist myself, and I'm on the convening committee organising the translational stream in the ANZUP ASM program. So it's a great pleasure to spend some time today learning more about what we've heard this morning from Marianna's presentation. Marianna, maybe you could just tell us a little bit about who you are and where you come from.
Yes, so I'm a professor of experimental urology and translational experimental urology in Bern in Switzerland. And this is the first time here in all the way in Australia, so I'm really excited to have joined you guys here. So thank you again for this beautiful invitation. And one of the focus that we have in the lab is really translational medicine. So, and we try to do this applying organoid and organ-on-chip research to directly patient material. And I think that one of the strengths that we have in Bern is that now, after a bit of a battle, I would say, I also participate in the tumor boards where I think all the action actually happens and how you actually see how what you do in the lab is applied to translational research and to patients.
We're really proud to have that environment existing here within the ANZUP network in Australia. And, you know, the translational science session this morning was really well attended because we have genuine buy-in from the oncology discipline and all of the other disciplines coming together because we think we can do better when we come together.
Yeah, absolutely.
So
But I really find what you guys have going on here is really fantastic. I've been speaking to people, and I have seen and I've heard the level of the translational research you do, and I also love this patient involvement that you have here at ANZUP. I think it's really very powerful.
yeah, we had a very special talk from Will McDonald this
Yeah.
morning. I think even I was nearly brought to tears, and I know Will very well. So I think it always grounds us in the reason and
It
purpose that we're
does.
all.
It puts things into perspective and gives you purpose and reality to what you're actually doing because you see that people do benefit from what you're actually doing.
And we meet those people.
Yes, and we do, and we meet the people. It's really fantastic.
So I just want to spend some time talking about your beautiful presentation. As I said, your slides were beautiful. I really enjoyed and the complexity of the work that you've completed was just a beautiful showcase of your research. So maybe you can tell us just briefly about the approach that you took, which was looking at the individual cells in a tumor and how they're spatially arranged and talking to each other.
Yeah. So the idea behind this is that what we do in prostate cancer, or I would say in cancer in general, is that we look, or the pathologists look at the morphology of the tumor and define the stage of this disease. And what we thought was to take this to another level and to say, well, if you can define also spatial interactions among cell types, maybe this could better refine the stratification of the patient and the definition of the progression of the disease right off the bat at diagnosis, which would be a great achievement if we could come to this point, I would say, for many different cancers, not only prostate cancer, I would say.
But what you had to go through to set up this process of obtaining specimens and analyzing them in such a deep way was quite involved, right?
It was painful, I believe, is the word I'm looking for. Well, it was a very deep, it was a very long process because we had to identify the correct patients that we wanted to analyze, and then we had to set up the whole model to make it work. The image mass cytometry is a novel technology, not so novel anymore now, but the process of analyzing it is in theory, which means that for every different kind of tissue, you have to set up a whole computational pipeline to understand and to analyze the data. And the most difficult aspect of this was actually to create the segmentation. And that means basically to identify each kind of cell and the boundary of each cell type. So, and this is what was really time consuming, and we had to go really back and forth between the wet lab scientists and the computational biologists, because ultimately we could not identify the stromal cells as we would wanted to identify them by marker of cytoplasmatic or membrane. So we had to revert back to nuclear segmentation. So that, I would say, in a way, is a bit of a limitation of the study, or a limitation of the technique and technology that is out there still.
And so I recall that you had 195 patient specimens in your study and
Yes,
4 samples from each of those. I
that's
mean, the
correct.
investment in time in finding those regions must have
Yes.
been just incredible.
Yes, it's been very challenging. It took us about a year to do it took us about a year to optimize the antibody panel, and then took us another year to actually generate the segmentation data. And the interesting aspect was that to run all 7 slides of the TMA took about 7 months of time on the machine.
Wow.
So the whole process was very much time consuming. And of course, that also meant that there was bias among the different slides because not everything could be run at the same time. So there were batch effects that we had to account for as well. So it's been quite a process, I would
So
say.
many questions. I'm gonna focus on 2 of the main findings that I heard from your presentation, and one was about this really unique population of epithelial cells that it both express ERG and P53 in the
Yes.
same cells. So I mean, really linking with poor prognosis. So we really start
Yeah.
finding. Do you think we can see those cells if we start looking for them in a biomarker approach?
Probably if pathologists would do double labeling for these cells, I think they would see them. Yes, I don't see why that would not be the case. And I actually think that processes like image mass cytometry or multiplexing should become a routine in pathology, I believe. And the pipelines for the analysis of these complex multiplexing should also become a routine process that we have.
I'm sure it will as a technology advances.
Yes, of course. I think that one of the other things that my lab has developed is a virtual multiplexer that we published also a year and a half ago. And I think this also very much helps in the identification of these kind of cell population because we generated an algorithm that without the staining can predict the staining of 44 different antibodies. So if one would use the ERG and the P53 as well, you basically wouldn't have to do the staining. You would just have to run the pipeline of the algorithm. And then the pathologist would see if this particular population is near or not the other troubled population.
Yeah, so that was my next question,
Yes.
actually. So you challenge the field to think about whether prostate cancer is actually immune cold,
Yes,
because there are some really active immune responses
that's
going on,
correct.
but those immune niches that you identified were really instrumental in
Yeah. So what we identified was 3 kinds of different immune niches. And what was absolutely remarkable of these immune niches was the fact that um, not all of them, individually, they are not prognosis of anything. But what we created was an immune score of these niches. Is only when you combine these different niches together, then you can define a score for which that can be associated to prognosis and to survival of the patients. So I think that's what is the power of basically what this tells us is that the kind of analysis that we have to do at diagnosis cannot just be an analysis that limits itself to an H&E. We have to go more in depth to try to understand what kind of tumor we're dealing with, because otherwise I don't think the understanding of the tumor is complete. So
there's clues in there.
yes, they are. Yes. So we should try to put more effort in understanding the individual biology of each tumor. I think this is actually the basis of what maybe one day will really be precision oncology.
You know, we're heading.
Yeah.
I've just got one final question before we wrap up. And we're at the ANZUP ASM here, and prostate cancer is the most common cancer of all of the GU cancers. But we have people here interested in testis and bladder, kidney, and all the GU organs. I mean, do you think this sort of spatial technology will then flow through into these other cancer types with time?
Yeah, so I do think that, so as a matter of fact, in terms of bladder cancer, we are working on this. So we have already advanced in this aspect. And as we are actually speaking, the TMA is being running on a xenium as well.
Cool.
So,
Okay.
you know, we are
So
trying
bladder
to
cancer
move.
next, and then opportunities for other cancer
Absolutely,
services.
absolutely. But this is where I would love to also collaborate with all of you guys because, you know, you also have unfortunately, the population, but that means that you do have the patient population and the TMAs that could, you know, make us go forward faster, I would say.
Well, let's use the next couple of days to
Yes.
build those collaborations.
Absolutely.
So thank you very much, Renea. It was really fun having this conversation
Thank
with
you
you
very
this
much.
afternoon.
It's been a pleasure.